Alright, so okay, I think I can see myself clearly in the preview there. Alright, so we are live. Okay, so now what you need to do is just to go and look at topic 4 slide here. Okay, we are going straight into loops, which is your chapter 4, but basically inside chapter 4 you are going to combine what you have learned in topic 3 as well. So you are basically learning two topics within this chapter. So you are not just learning you're not just learning repetition without implementing selection structure. You are doing both. So introduction to loops. So as you can see, this is GIF showing you looping roundabout here. People keep on moving. The car keeps on moving around this roundabout. So as you can see on this slide, there is a bunch of unnecessary stuff going on inside here. This is Mirza is your senior. I'm not sure if you know her. So this is basically me giving her the example of doing something like animation for her code. This could be tested out later on if you plan on applying the same method, but we just skip this part first. We go straight to the introduction. Okay, a loop is a programming tool that repeats some code or set of instruction until a specified condition is reached. So you need a condition in order to figure out how many times you are going to repeat the code. So as a programmer, you will find that you rely on loops all the time. Okay, we are playing with loops. Okay, to create a complete code, you need to implement selection structure, and then you also have to implement the looping. So otherwise the code would be too simple. There is no sense of repetition. There is no sense of complexities in your code. You will hear the generic term iterate. Iterate is the fancy term that the programmer use. Okay, the computer programmer use the term iterate to signify repetition. Basically, it's the same thing as repeat. Okay, to repeat something is to iterate. So you don't use to iterate while you explaining something that is related to repetition. So you just use the term repeat. This might be the first time you hear this iterate term. Okay, when we see that a process has to repeat multiple times in a row, we write a loop. Loops allows us to create an efficient code that automates processes to make scalable, manageable programs. So in this lesson later, you are going to learn multiple types of loops, but first we are going to see on while loop. So there are 5 types of loops that exist here, okay, as you can see in this slide right here. But let's look at the flowchart of repetition first. Okay. There may be a situation when you need to execute a block of code several number of times. Basically, you have this flow right here is something similar to your selection structure. You have condition, right? So in your selection structure, you might have a true or false condition. Okay, if the condition is true, you do something. If the condition is false, you do something. But for chapter 3, after doing either one of them, you would go straight to the next process, which is right after the condition that you are going straight down. But here in repetition, you are not going down. Somehow, if one of the condition is either true or false, okay, you might want to repeat the process all over again. So as you can see right here in the flowchart here, you have a condition. It coming from somewhere up here. Okay, you might have a bunch of operation up here. It might be like declaring a variables. You might be assigning a value to a variables up here. or you might be inputting some value using cin up here, and then you go here and then you check the condition that is related to the variable. So if the condition returns true, then you go up here, which is the statement that you are going to execute conditional code. And then after you have finished executing those code, you will return back to the condition, and then you check the updated value of that condition. For as long as the condition is true, you will keep on rotating in this area. But once the condition has returned false, then you go to the next statement down here. You proceed to the next statement. You are not going to repeat the code all over again. Okay, so here are the 1, 2, 3, 4. Sorry, I think I mentioned 5 earlier. So there are 4 different types of loop. One is while loop. The other one is actually do while should be right after while loop. So I need to put it here. Okay, so the first looping method that you are going to learn is while loop. That is the easiest one. Okay, this is easy level, and then this is quite easy as well. It's still easy. This is a little bit difficult. This is, I can say, is complicated, or it's a little bit like this is scarier version of looping, and then this is ultimately gonna put you in the coffin dance mode. So nested loop is the hardest one to understand in this topic, but for loop is actually the most complicated version. If you combine if there are 2 for loops in your code, it will lead to this coffin dance. Okay, so we can go straight away to while loop demo here. Actually, this was taken from Code Academy. Okay, I just need to mention it earlier because you are about to see I'm demonstrating it inside Code Academy as well. But I do have the code right here with me. Okay, here is the snippet, the code snippet right here. Okay, what you need to do is copy the code. Okay, if you are on your laptop now, so let's do this together. Okay, you have to actually the code, the file here somehow is not updated. Actually, the topic 4 is not updated. I'm not sure if I can like edit and then add the file or no. I'm not sure. I need to get the updated version from Google Slide. Actually, the updated version was in group A. Somehow it didn't update here. I don't know why it happened to be like that. So it was supposed to be the same with the other group. Don't know why, but never mind. It's almost similar to the one that I have in group A. It's just that it's not that as fancy as their version. Alright, so let me close this first. Okay, let me open up my, I don't think you need to see all this. Okay, atom. Okay, inside my atom I will create a new file and then paste the code right there, and then I will save the code inside here, and then I name it as playground as usual, playground.cpp. So that is my code right there. Okay, I will explain it to you line by line later on. So do I need to show you anything else other than this? Maybe I can look at the chat. If you were to I didn't on my right. Okay, so I have my terminal with me as well, so that you can see the execution later. I can make it smaller. This. Alright, so now we have 3 panel window. This. Okay, so here is your code. This is very basic code actually. Okay, I can remove this standard colon if you don't like to see that in the code, so I can use the using namespace std, and then I can replace. I can find the standard notation here, and then I can replace with nothing, so that it can be like this. So here is my updated code. Okay, I need to change this first into like UiTM CS Bank of UiTM Cawangan Sarawak, something like that. Okay, because the code was taken from Code Academy, that is why you saw the name Code Academy there. Alright, let me show you how it runs first before I start explaining the code. This code is not really entirely new, other than except for line 15 until 20. The rest are pretty much similar to chapter 3. So let me run the code real quick. G++, click run. To compile the code, you use G++ command, and then to run the code, you use ./a.out. Okay, enter your pin. Okay, the question here is the prompt here is asking me to enter the pin. Okay, if you look at the code, you might know that the correct pin is somewhere here. See, pin accepted, right? So the pin that is accepted is basically 1 2 3 4. So if I press 1 2 3 4, pin accepted, you now have access. Okay, but if I rerun the code once again, if I put 1111, it will ask me to re-enter the pin. Then see if I press it one again. So one more time. Okay, if I do that again, I do that again. Okay, and then this is gonna be the last time I can enter my pin before the program exit. Okay, the program exits due to the fact that my condition is no longer true, but we will discuss on that later. And you are looking at 5 input prompt here, so there are 5 here, 1 2 3 4 5, but actually the repetition only happens 4 times. Okay, these are the repetition part. This is basically the initial prompt outside the repetition. So let's look at the code real quick. Okay, semua okay? 25 of you is still here? Are you guys still here?
Okay, sir. Okay.
Alright. Okay, if you don't want to, because I am looking at the chat, you can always just put okay here at least. Okay, because I would know if you are not joining the class.
So if using namespace std, no need to put standard colon now.
Tak perlu. That is the reason why I want you to practice using namespace std here. Without using namespace std, you will get an error. Okay, see, a bunch of error here, all this crazy error, but they are basically all the same. They are just talking about, I couldn't find this cout. Where did you get all this cout? Or what are you referring to? Cout. It says something like that. Undeclared, cin, undeclared. Cout is simply because you are not telling the compiler this cin, this cout and cin is actually coming from IO stream, but it comes from the standard library. So that is why you need to declare this using namespace std. If you don't prefer to use this method, you have to write the standard colon all the way. Okay, for every cout in the code, you have to mention this in front. So I don't want you to do that. Okay, your code will get so messy with standard colon notation. So it is best practice to using namespace std instead. You understand that? We are at week 9 now. By right you should be able to grab that method already. Okay, that structure is should have stick in your head already, this method of declaring using namespace std. So you won't see the error anymore. You can basically proceed with the execution. Okay, so inside this program right here, you have two variables. One is pin. You assign 0 to it first. This is just considered as the initial value of pin. Okay, I need to make it smaller here so that I can write some comments in the middle. Alright, so you are basically declare a variable pin with data type integer. So the variable pin later can be used to store any integer value. Okay, an integer value. That is why I'm putting this 0 as my initial value there. And the next variable that we declare is thrice. Thrice is basically how many times we can retry the code. We can retry inputting the value or the pin number. Since this is basically like a pin verification for your ATM machine, consider this as your ATM machine. There should be some limitation. You cannot just keep on retrying the pin number for as many times as you want, otherwise people could hack your account. So we need to put some limitation here. So we can only give them like 3 times of retrials. Oh no, 4 times of retrials. I will explain that further. Okay, so this is the number of retrials, the number of pin input retries. Okay, so this is just the title of your code here, bank of your MCS, and then I ask the question, enter your pin, so that you can look at the prompt here. So you can see bank of your MCS, enter your pin, and then you look at this blinking cursor is actually waiting for your input. So if I input anything other than 1 2 3 4, if I press enter, it will ask me again. If I put 2 now, it will ask me again. 3 still wrong, 4 still wrong. If the 5th one I got it wrong again, something like this, I put 5 for example, then the program will end just like that. It doesn't tell you anything. So this code is not that perfect, it's not complete. Okay, it's not the best code for even the basic task like this. You have to mention something at least. If the person got it wrong for all the 4 retries, you have to say something to them. But it was not done in this code. That we will do that later. I will add some statement down there just to tell the user that you have entered too many invalid input. So please wait for a while before you can reuse the system. So that is just the first input here. I was explaining the first part only, not entering the loop yet. Okay, now we enter the loop. Okay, while, here is the keyword that we use, while followed by parentheses. Inside the parentheses is where we have our condition. Okay, if you use atom, if you write while, and then as you can see there is a suggestion here, suggestion call out. You just simply need to press enter to complete the code. This is what we call autocomplete in code editor. So as you can see right here, it states condition inside the parentheses, and then inside the curly braces here it says code. Basically any code that you are wanting to repeat. So looking back at this condition right here, you have two conditions basically. It's combined with this AND logical operator. So the one on the left is your first condition, the one on the right is your second condition. So the first condition here states that if, it's not if, is pin not equal to 1, 2, 3, 4. Okay, this is basically to compare the number that you have entered here. Let's say I entered 1 just now. So is 1 not equal to 1, 2, 3, 4? That is true. 1 is not equivalent to 1, 2, 3, 4. So this condition will return true. And then look at the second condition on the right hand side. Thrice is less or equal to 3. Okay, the value of thrice in the beginning of the code is 0. So currently thrice is actually the value of integer 0. So is 0 lesser or equal to 3? Yes, it is true. So true as well. Okay, since both condition returns true, and then you apply this AND operator here, true and true will return true. Okay, true and true will return true. In that case, the while loop, okay, the while loop content will be executed. Okay, that is how repetition works. Okay, let me revert back to the original form. Okay, as you can see right here, it will go into this statement. Okay, once you got the first input wrong, it will enter the loop. But you are looking at the same instruction. This is the first instruction, enter your pin. The second instruction is actually not this one, not coming from line 12 anymore. It was it was for the first prompt here. The first prompt was coming from line 12 of my code here, but the second enter your pin prompt is actually coming from my repetition body here. So I can modify this a little bit. Rather than saying enter your pin once again, let's just say re-enter your pin. It seems like he already missed the first input just now. He got it wrong for the first time. So the next time you need to change the instruction a little bit. Re-enter the pin number. The rest you don't need to change. Okay, as you can see, I'm just adding this RE dash in front of enter, and then I need to recompile the code. Okay, as you can see right now, let me just input a wrong number once again. So 1 is not the password, right? 1 is wrong, so this one is false. This one is true, so false versus true is gonna return false. Sorry, this one is gonna be true. Okay, whenever I enter 1 just now, I think I have mentioned to you earlier, I've explained it to you earlier. So whenever I enter 1 right here, this number just now, pin, is gonna be 1. 1 is to be compared with 1, 2, 3, 4 using the relational operator not equal to. So 1 is not equal to 1, 2, 3, 4. So that is true. That is what I mean by true here. Okay, so reverting to this form. Okay, let me enter 1. As you can see right here, it will change the prompt a little bit. Re-enter is coming from line 17 here. So re-enter your pin. Now you know that you are already inside the loop. Okay, you are no longer outside the loop. During the first prompt, you were outside the loop. Now you are inside the loop. Okay, now we can re-enter 1. Okay, this is my first try. Okay, this is my second try, third try, fourth try. That's it. You are only given 4 times of retries. Okay, so after you have got all the 4 input wrongly entered, you will be exiting the code, exiting the loop, and then there will be nothing being printed out because you got it all wrong. Okay, let me repeat the demonstration to you. Let me use other number here. Okay, 9. So 876. Okay, actually this is the last input that I can do here, so I need to write the correct input to get the pin accepted here. Okay, or I can do it straight away. 1 2 3 4, that's it. But the problem is that when we input all the wrong value, there is nothing being printed out at the end of the code. This is actually the end of the code, right? The end of main loop. So this is the end of main function. Okay, this should be printed once you get the password right. But if you get it wrong, for all the retries that you were given, you need to output something here. So we can add the else statement here. Okay, this is gonna be a two-way statement now. Before this, it was a one-way statement, which is you have one condition here and then you only have one outcome. You don't have the next outcome. You don't have the opposite outcome. What if the pin is not 1 2 3 4? Do you need to do something with it? So we are going to do something with that by adding else, followed by these curly braces here, and then inside these curly braces I can see out some message here. Too many incorrect input. Please wait 5 minutes to retry, something like this. Okay. Okay, now let me rerun the code. I have added this else statement, okay, with these two lines of code here, the cout statement there, and let me recompile and rerun the code. As you can see, one. Okay, let me do the 1 2 3 4 thing. 1 2 3 4. As you can see, it output too many incorrect input. Please wait for 5 minutes to retry. As you can see, this look much better in the eyes of the user of the program. Basically, they understand that, oh, I got it all wrong, so too many inputs, so I am not allowed to input anymore, so that I need to wait for a certain amount of time. Okay, even though we are not doing anything with the timing yet. Okay, it's not in the code yet. It's just the statement. I'm just stating that we need to wait for 5 minutes. There is no process involved in that. Alright, okay, are you okay? Are you still with me? Are you guys still with me? Respond now.
Okay, on join, sir.
Yes, boss.
Apa dek? Baru join? I heard something just now. Apa yang kamu cakap? Alright.
I'm trying, sir.
Okay, looking at the, yeah, we are going to analyze this code really deep afterwards. So you have to keep it up with me. Okay, so I have demonstrated it to you just now. To have your statement inside the repetition body to be slightly different than the initial prompt. As you can see right here, the initial prompt is outside the repetition. It cannot be inside. Otherwise, there is nothing to do with that. Okay, so you need to have the initial input first before you start going into the repetition body. That means your retries is basically 4 times plus the initial input 1. So they are actually 5 times of retries here. It's not 5 times of retries. It's actually combination of the first input with 4 retries. So you get 5. Okay, looking at the tries here contains this number right here, 0. But after it has finished executing all the process inside the loop body, as you can see, right after you enter the retry pin, okay, the new pin later, you will need to increment the thrice value. The thrice value is now being incremented by 1. You are applying post addition. Oh no, not addition. We don't call it addition. Post increment method. After the first retry input, the number of tries here will increase by 1. So here the try will go from 0. Okay, the first time you go into this loop, it is 0, and then once it has come to this line, it will update itself to 1, and then it go back down here, it repeats the process, and then it will be incremented by 1 again, so it becomes 2, and then it goes back inside here, and then it will add 1 to it again, so it will go up until 3, and then once you have reached the 3 mark here, okay, it will go and do that once again for you, and then it will add one more value to it, which is 4. It's gonna be 4. And right here, if you look at the condition, this is now obviously false. Okay, so this is gonna return false. So whenever this is false, even though this is true, even though this is true, the output of this logical operator would be false, because this is AND operator. AND operator, whenever one of them is false, then the output is gonna be false. So if true and false, you are gonna have the output as false. So while false, you are not going to do anything in the repetition body anymore. Okay, you are going to skip the repetition all the way, right? So that is basically regarding condition in the while loop structure here. Okay, so this thrice plus plus, it can be replaced with other method of incrementing the variable. So you can also use this standard mathematical expression here, thrice equals to thrice plus 1. You can do this as well. Thrice equal to thrice plus 1. You can change that. Then we can retry that with the demonstration here. 1. So too many input. Oh, sorry, I forgot to change this back to thrice is less or equal to 3. Okay, so 1, 2, 3, 4. See, you can use this method. And there is another alternative. You can also use thrice plus equal to 1. This looks rather confusing to you, but this is actually basically the same as line 20, right? Thrice plus equal 1 is just equivalent to thrice equal to thrice plus 1. It's just the short form for this expression right here, the shorter method of writing the code. You can practice this using this method. Okay, the other one is gonna be the opposite of post increment. You can also use pre-increment. Okay, pre-increment, you do the plus plus first and then followed by the variable name. This would result in the same thing as well, so I can test it out to you. See, just wait for 5 minutes. So these are your options here, and then let me use the original one. Once again, I need to remove all this so that the code looks simpler now. Okay, here I want to teach you something that is very, very useful for you. Right here, we are declaring the correct password, right? That is the correct password. You know that because you are the one who write the code. Okay, 1234 is basically the correct password, and other than 1234 is basically the wrong password. Okay, anything other than 1234 is gonna be wrong. Okay, So only 1234 is the correct password, the accepted password. So why don't you specify this correct password as a variable in the beginning of the code? Something like this, int correct password. You name the password with a variable that contain the number itself, which is 1234. Okay, so that you know pin is the one that user enter. User is going to input some numbers, and that numbers is gonna be stored in pin, in that container. If you still remember the term container that I used before, pin is just a container. You put some number inside, and then you compare the number inside that with the correct password, which is 1234. So here we can write, instead, rather than you write the password explicitly there, it is better if you write it this way. If pin is not equal to correct password, then you repeat the process. Yeah, it sounds much better, right? Okay, does it sound much better, guys? Can you respond?
Yes, sir. Yes, sir.
Okay, so here you can literally say, you can verbally say, if pin is not equal to correct password, then you do this. If it is equivalent to correct password, then you go outside the loop. You don't need to do anything here. You just go straight down here, which I will explain later. This is the one of the thing that I want to change here. I didn't do this in the previous class. That is why I wanted to do this with you. And then for the tries here, rather than specifying the number of times explicitly like this, 3, does it mean anything to you? For you who just went through all this explanation, you might understand 3 is the maximum number for my tries here. It starts counting from 0. So 0, 1, 2, 3. That's why we have 4 retrials. Okay, we have 4 retries here. 1, 2, 3, 4. Together with the first input. So all in all, we have 5 input altogether if you got everything wrong. So if you got it right during the second retry, then you will exit the program, the loop straight away. So you are just gonna have 3 input. For example, let me demonstrate it to you. You might want to see the example in demonstration. Okay, so I have entered 2 wrong input for my retry, and now I just enter the correct one. So pin accepted. So the loop will no longer be repeated. I hope you understand that. Once you get the password correct before the condition gets false. So for as long as the condition is true, you can still repeat the process. So rather than explicitly showing the number 3 there, that doesn't really mean anything if you show this code to other people that has never been briefed with this code earlier. So they will not be able to interpret what is this 3, what does this 3 means. So why don't you put that number 3 inside a variable as well, something like maximum retry, max retry. Okay, 3, we declare this variable called max retry, and we assign the number of 3 to it. The type is int. So here, rather than writing 3 there, why not we make it even clearer for people to understand? If tries is less or equal to max retry, which is 3, then you keep on repeating all this process. So that is the way of writing your repetition body. Okay, this is what we call repetition body here. Okay, once the user entered something like this example just now, once the user entered the correct password, it will exit the code immediately, exit the loop immediately, and then it goes straight to this conditional structure. Okay, if pin is equivalent to 1 2 3 4, obviously you have input, you have entered the correct input, so the pin is now 1 2 3 4. So if 1 2 3 4 is equivalent to 1 2 3 4, so this is gonna be returning true. If true, then you do pin accepted. If false, if all the input were wrong, then the condition down here is gonna be false. So it will execute the statement inside the else structure here. Okay, it's not gonna be outputting this pin accepted anymore, right? So that is how you do the checking of pin number. So what else? Okay, that is basically it. I hope that you can understand this example as much as possible, because this is the most basic example that we can have. We can play around with while loop if you want. We can play around with this actually. Basically I can stop playing around with this bang right now, and then let's do some activity regarding while loop here. So you have while just now, and then with the condition inside here, and then with code inside here. Alright, you have this condition. Condition could be false or true, right? So while false, let's show you something here. Do something. Okay, I'll just write do something, or repeat something. Repeat this statement. Okay, and then down here I just put end of program, or just exiting loop. A loop exited. Okay, loop exited. Okay, this is just my basic example of how the looping works. As you can see right here, I didn't declare anything, right? In the code there is nothing being declared. It's just having this while structure followed by this cout statement in both inside the loop body and then outside the loop body. And since my condition inside here is straight away false, without comparing anything, without doing any relational operation, without using any logical operation, I put the false statement straight away. Okay, false is just boolean, right? This is boolean in C++. The opposite of false is true, but let me explain this first. As you can see here, the condition is already false straight away. So if the condition is false, it would not be executing the content of the loop. It will exit the loop straight away. That is why you see it prints out loop exited here. Okay, it goes straight to line 11, meaning your code start from line 7, let's say, because inside your main, the first line that has some code in it is not 6 is just empty line, but on line 7 you have while false. So the condition is straight away false, so no need to do the loop, no need to repeat the thing. Okay, no need to execute the content of the loop. So you do this straight away. But if I change this to true, you're gonna see my computer go haywire. Okay, you need to see the screen all the way from top to bottom. Okay, be prepared, guys. So I'm compiling the code, and then let me rerun the process. As you can see, repeat this statement is being repeated so many times very fast. As you can see, the scroll bar it moved very fast to the top. It keeps on scrolling now. As you can see, my CPU is being burdened by this process right now. As you can see, the terminal is consuming 110% of my resources, and my temperature is going up, because the CPU is doing so much work to repeat all this statement. This keeps on being printed out for as fast as the computer can perform. So right now I have already millions of repeat this statement. Thousands, sorry. I think it's just reaching thousands of numbers here. As you can see, there are so many repeat this statement. This might not look that clear to you because you just keep on looking at repeat this statement all the way again. So all the way from top to bottom. As you can see, if I'm scrolling up, you can see my initial execution here. This is me executing the code, and then as you can see, starting from here all the way to the bottom, I don't know how many thousands already it has repeated this statement. So let's just declare something up here. int. We need to declare long integer for this. Long integer count. Let me put count here, and then let me start from 0. Let's start counting from 0, and then inside here we do this. Count equals to count plus 1, and then here we can also add something to this statement, or before we put that sorry, I just need to make it like a full statement here. Repeat this statement for the count times. So as you can see, later it will print out repeat the statement for the first time, repeat the statement for the second time, repeat for the 100 time, 1000 times, as you can see later. I'm stressing out my computer now. As you can hear, you might be able to hear my fan gets very loud right now because it is spinning at 100%. Okay, so let me rerun the code for you. Are you guys still with me? There are 25 of you still.
Yes, sir.
Sometimes you leave the chat and then sometimes you rejoin again. Okay, now I am rerunning the code, but later you will see an additional number gets printed out. As you can see, the number quickly reaches 1 million marks, 2 million, now it's 2 million, now it's 3 million, 4 million, this is million, right? Million, 5 million times, 6 million times, 7 million times, 8 million times, 9 million times, 1 billion times. Yeah, I don't even know what to say anymore. 1 million, 1.2 million, 1.3 billion, 1.4 billion, right? I think that's how you pronounce that number. I think it's million. 1 2 3 4 5 6. So this is 16 million, right? This is still 16 million. Sorry. We have not reached 1 billion yet. This is actually 16 million times. If you try this in your own laptop or PC, okay, you might not get as fast as this computer can, due to the fact that I'm using a Core i9 CPU. I have 8 cores to do the process, to do the calculation. That is why in 1 second I can do so much calculation compared to whoever is using Core i3 or Core i5 CPU. You can try this on your own, and you can refer to your own output later to see if you can reach from 1 to, what was that? I can't remember. I think it's from 1 to 1 million in just 1 second. Let me rerun it once again. it goes straight to 3 million if I'm not mistaken just now. If you quickly catch the running output. So in 1 second I could reach like 3 million calculation. This statement is being repeated for 3 million times in 1 second for this computer. I'm not really explaining to you about this. Okay, this is just to show you the number of times it has been repeated. But basically, for as long as the condition is true, you will keep on repeating this forever until the program crashes. Okay, it won't go for as long as it wants. Your computer will be out of memory. Okay, your computer will be in the state of overflow. Okay, the container to store the number count later gets overflow. Just now I use long integer to declare this count variable because I want to have a very massive container to store the number. But if I don't mention long in front here, okay, and then I run the code, I need to recompile the code first. I will get to the point where I'm not sure of how it processes the number here. The number should have reached some limit already because int, the range of number for int is very small basically. Now I have reached 11 million. It's not as smooth as before. By right it should be overflow. I'm not sure why it doesn't overflow for my computer. There is another version of int which is short. So short int. This is even shorter than the standard int. As you can see right here. Now I can demonstrate it to you clearly. If you were using short, then you are only allowed to go until 32,000, I guess. Can I scroll up so that I can see the maximum number here? The maximum is 1,000. Alah, it's too many numbers inside here. Okay, look at where it meets. From the last positive number to the first negative number. As you can see right here. So you can see here. This is what we call overflow. Okay guys, are you guys looking at this?
Yes, sir.
Okay, due to the fact that I am using a very small container, I actually short int is the one that's having the limit from the largest number that you can store inside short int is 32,767, and the lowest number that you can store inside short int is negative 32,768. So you can only play around with the number in between if you plan on using short int. Do you understand that?
Yes, sir.
Once the container gets to the point of this number here, this maximum number, there will be a phenomenon called overflow in computer programming. Overflow simply means you are having the water reaches up to the top of the container, the bottle, and then it spill out. Okay, the water will get spilled out if you fill it up to the maximum point. So the number will get to the other side of the spectrum, which is the negative side, and then it returns back to the zero point. As you can see, the number now keeps on increasing again, and it goes all the way back to positive number. It goes all the way back to zero. As you can see from here, my scroller is too fast. Okay, as you can see here, it will meet back at -1 and then 0, and then it repeat the positive cycle once again. So it goes from positive to negative to positive to negative. So that is regarding variable. It's pretty interesting for you to know right now, meaning that if you plan on playing around with large number, you stick with the standard int. The standard int won't get overflow by this process, meaning the standard int can store a very large number, even larger if you use long int. Okay, that is how we repeat the statement. So without doing this, without doing the variable update, we call this variable update. So I'm updating the counter of this code. So without you updating the counter, what's gonna happen is that your count will remain at 0 because it is not incremented in the loop body. So it stays at 0 but is now repeating. It is now being repeated for millions of times already. But you are not looking at the changes of value. That is the problem here. That is why you need to have the variable update to see how many times the program has been looped. So I hope that this is very clear to you already. Therefore, we can proceed to our next slide here. So the next slide is basically guessing number game. This is actually taken from Code Academy as well. So the activity is better being done in Code Academy rather than me doing it manually. But this part right here, I can do it together with you, since this is the one that I did with group A this morning, right? And then you will learn about for loop. Keep for loop for the next session tomorrow. But for now, let's look at this while loop right here. Okay, the last one, we held your hand. This is basically what Code Academy tells you when you do the activity later. An example of iteration, we have the first program ever to run on a stored program computer. This is basically the situation. It was written and run by David Wheeler in the computer lab at Cambridge University, England in 1948 to calculate and print a simple list of squares like the following. So you have the number on the left and the number on the right. So the number on the left is basically just a normal integer from 0 to 9. But the number on the right is basically the squared value of the left number. So 0 is, the square of 0 is 0, the square of 1 is 1, the square of 2 is 4, the square of 3 is 9, and so on. So by using this template right here, just a short template for you, okay, you copy this, and then let's do this together. Okay, let me replace everything here with this. Okay, so you have been given the variable I. This I will be the number on the left, and square will be the number on the right. So you will just create a simple table looking like output. So your output might look something similar to the one that is shown in Google slide just now. So how to do this? Okay, first we need to declare the variable, which has been done for you. Okay, you have two declaration up here. So now just let's start off by writing the while condition straight away, while, and then you need to remember, if you are not using atom, so you have to do it manually. If you use it, if you use something like development C++, I think you can pretty much have this auto completed to be used in the code editor of your choice. Maybe code block has this function as well. I can't remember. I'm not using it now. So while you have to enter the parentheses and then followed by the curly bracket. So inside the curly bracket here is where you put your condition. So your condition now is related to I. Related to the variable I. You are not dealing with square. Square is just the output of your statement inside the loop body later on. But the condition here must related to I. How do you want your I to be in your output? So look at the why I'm looking at the wrong stuff here. Okay. So my I should start from 0 and then it should stop at 9. So how do we do that? So you can see you can put the condition like this while I is lesser than 10. While I is lesser than 10, meaning that the last number of I would be 0. It would be 9, sorry. Would be 9. So let's just look at the output real quick. See out. And then I will output I straight away here. And then followed by ENDL right next to it. Okay. So let me run the code real quick and see what happened. Something bizarre will happen, but I'm just trying to show you what's gonna happen here. Oh, okay, I forgot to. As you can see, since we didn't declare that using namespace std, yeah, it comes out as this error message here. So don't forget that. The program expected us to use the standard colon method, but I don't like to use that. Instead, we use a single declaration here. Okay, so now we are ready to compile, and then let's run the code. As you can see, it is something similar to printing out the multiple repeat this statement demonstration earlier, but now you are just looking at 0. Why the heck you keep on looking at 0 value? Why does the value doesn't change? Why doesn't it change while executing? Because it turns out that while executing this code right here, you didn't update the value. You need to update the condition here to a new value for each loop, for each repetition, for each iteration. You have to update the value. So always remember to use the post increment method or other method that I have mentioned earlier. You can also use this plus equal to 1 method to update the value of I, but to make it simple, we use post increment. So now if we run the code once again, you can get the value starting from 0 only up until 9. It's not gonna be printing out anything more than 9. Anything beyond 9 is not gonna be printed out, simply because the condition will no longer be true once the number has exceeded 9. Okay, 9 is the largest number that will make this condition true. Otherwise, for as long as the number is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, the condition is always true. So we have to repeat the cout statement here. We have to repeat the updating variable updates. But when it comes to the last one, which is 10, you add one more value, you increment I by 1, you will get to 10. Then the program will check if the condition is true. Now the condition is no longer true, so it will return false. That is why it skipped the statement afterward. So that is how you write the condition. But there are some alternatives for you while writing the condition here. I will show it to you now. If you just if you want to write it this way, it is up to you. But if you want to change it differently, you can do it this way. You can put 9 there, you can put number 9 exactly right there, but you don't forget to put equal sign for your relational operator. So like this, if you run the code, you would see the same output being printed out. But if you forgot to put the equal sign there, it's now less than 9 only. The condition now is if I is less than 9. So if I run the code, the number will get from 0 up until 8 only, because 8 is the last number that will return as true. Okay, well, that will let this condition returns true. So you need to play around with the relational operator. You need to really understand what you are supposed to do, okay, for this problem. Okay, enough with that. We have managed to output the first column here. Our next objective is to output the second column here, the second column, which is the square of the number itself. So it is as simple as adding one more insertion symbol and then followed by I multiply with I in between. So this is the easiest way for you to perform a square of a number. If you don't want to use the math library, I will show you how to use the math library later on, but let me run the code first and see the result. Alright, okay, we can see that the number, it gets printed out and it is basically the square of the left number, but why don't we have a space in between those two? Okay, since in the example right here we need to have at least one single space between those two numbers. So basically we are missing something to split them up. Okay, since this is just printing out the numbers straight away, you are not telling the compiler you want to space them out by a certain margin. So to space them out by a certain margin, add another insertion symbol here, and then in between these two insertion symbols, this one and this one, in between here, you cannot simply just put spaces, something like this. It won't happen. Nothing will happen here, or you get error. You get error because you need to put something in between. So the easiest way is to put double quotes, and then you need to press one space inside the double quote. Okay, that will create a single space margin there, as you can see right here. Okay, or you can also use, rather than you use the single space method, you can use /t, which is for tap, a single tap press. So you can see it gets wider here, the distance between these two numbers. Alright guys, okay guys, how is everything? Are you guys following?
Yes. Following.
I'm not sure if you guys are really following. Are you guys playing around with code editor as well now? Or are you just watching this stream? I'm pretty sure that most of you are just watching this stream rather than
I not yet scan.
okay, never mind. I don't really care about the scanning part. It's just that this topic right here, I hope that you really know how to use how to implement the loop structure here. Okay tak?
Inshallah, okay.
Response please. Okay, this number right here we can change to any other larger number. Let's say we put 20 here, so the number is gonna be up until 19. Sorry, 20, because I explicitly say I want the number I here to start from 0 up until 20. As you can see, the number will end at 20. Okay, So reverting to 9, because there is one more thing that I want to show you. Okay, as you can see, we get back the expected output up until 9. One more thing that you need to put your concern on is the location of this increment. The update variable here, the increment here, if you put it before the cout statement, it will result in a different pattern, as you can see here. Now you start from 1 and then you stop at 10. That is basically because even though you declare 0 in the beginning, once you get to the condition here and it returns true and then it gets into the loop body, the number, the I, gets incremented by 1 straight away. It gets incremented by 1 before being printed out. That is why you see the first value here being 1 rather than 0. And then when you go up until 9, okay, you as you go along this route here, so you start off from 0 tadi kan, so it will print out 1 here. Then you increment by 1, so now your try is 1 here. No, your I is 1, so the value that will be printed out is 2 because you will add 1 to it. Okay, whenever your I becomes 3 later, and your I is gonna be incremented by 1, so the one that is printed out is gonna be 4. So up until 9, let's just move straight to 9 here. When the number is 9 already, when I has been incremented up until 9, here you will be adding 1 to 9. That will give you 10 as the last value being printed out here, 10, and the square of 10 is 100. If you go return back to the condition here, so 10 is lesser than equal to 9, so the condition is no longer true, so it will exit the condition. That is why you don't see 11 being printed out, because once it get to 10, the condition is no longer true, it will return false here. So up until 9 only, but when the condition, when the I value is 9, the one that gets printed out is 10 because of this increment being placed wrongly. You place it earlier than the print out statement, so be careful with this. Where you put your incrementation, it is normally at the bottom of your while loop, not at the top, but it depends on your logic. Yeah, it is all depending on your logic. There is no right or wrong here basically, but you have to follow the instruction. If the instruction asks you to output from 0 to 9, so you have to follow this structure right here. If you do it differently, something like put it up here, then you will get an incorrect pattern, which is not answering the question. So you be careful with the placement of your variable update. So that is basically regarding while loop. Okay, as you can see from the slide, we can play around again with this example. Probably we can look at the Mirza Steamboat example right here. I'm not sure if I can. I don't think I can use my terminal here because I'm using Mac. This example only works on Windows. So if you are on Windows, yeah, I can't use this library right here for my Mac. But I think I can use my online compiler. Let's go and see if we can try it in online GDB. So let me change this. Let me run the code real quick. Oh, it is not running as well. The build failed because both the online and Mac version of compiler could not find this windows.hash. That is the only problem. But if you are on Windows, you can try the code straight away. I have no Windows to be used now, but I can show you with different library that I have here. I can use other library to make delay, but I can't remember what is the name of the library, so I have to search sleep C++ Mac. I can't remember what's the library use. Oh, this one I need to use. So rather than declaring Windows, I will comment that line out, but this line is required for you. You guys are using Windows, so you better stick with this. You don't use unistd here. And then I need to take the sleep for 1 second. Okay, I need to get this. I want to make a sleep 1 second process here. So here I will put this one, and then here I will put this one. Okay, let's see if we can run the code. Yep, can execute the code, and then I can run the code real quick. Doesn't work. Somehow it doesn't work. Is it too long? I guess it's too long. I guess it's not. It's not sure whether it is. Is it microsecond or millisecond? Why is it not happening? Oh no! No! What's going on here? Why am I getting this weird output? It's supposed to be 20 stars only being printed out. Should not be this many stars being printed out. I think I've used the wrong library. It's not suitable for my Mac somehow. Is there any library I can use? I will take some of your time a little bit here. Do you have class, guys, at 4? The class card?
No, sir.
No, sir.
No, alright, good. Let me look for the correct. You sleep. It is correct. For 6. I am for 6. Don't know why it doesn't work. 500. It doesn't work as expected. 500 you sleep. Yeah, it doesn't work. Don't know why. It is supposed to print out star 1 by 1. That was the thing that you're supposed to see, but it's easier to use on Windows somehow. I don't know why. Can I use this? Maybe Chrono. Do I have all this library? Let's try this too. Some of the things that in C++ can easily being done in Windows, but not in Mac. So it's good that now nobody is using Mac in this class. Otherwise, you would have some issue when you try something fancy like this. This is what I call fancy stuff. Yeah, it's not doing anything. Yeah. I'm not sure why. It doesn't play nice with me. But you can try it on your own. You try it on your own on your code block. In your code block, you can do that in code block. You cannot do that in online compiler as well. So the only function that you need to use is this one, sleep, to make your code pausing for a while, so pause for 1 second or pause for 0.5 seconds, something like that. So that is what I was trying to show you, but I didn't manage to do that. Okay, just imagine that it never happened. Yeah, it never happened before. So I guess that's basically it for the introduction part of our I guess I will do the Code Academy tomorrow with you. Okay, tomorrow morning, right? It's tomorrow morning. So I will go through the Code Academy with you guys tomorrow morning, and then I will do this guest number inside the Code Academy as well. And then we will proceed straight away to for loop. And then we might want to discuss on actually I forgot one thing. I think I can stop the recording now. I no longer there's nothing more to say the stream. So this is the end of the stream.